All right, here's the next example. I have 5x to the third, y to the ninth, over 20x squared, y to the negative 2. There's a lot of ways you can do this one. So you don't have to go necessarily in the same order I do. I always try to work with my coefficients first. The coefficients, and sometimes I just call them the big numbers, the coefficients you actually just reduce. So I'm going to reduce 1 and 20 goes to 1 and 4, because 20 divided by 5 is 4. Then the next thing I'm going to work with is my negative exponent. Since this is a negative 2 on bottom, it gets moved to the top. So instead of y to the negative 2 in the denominator, it's going to be y to the positive 2 in the numerator. So now I've got 2 x's on bottom, 3 on top. These two are going to cancel with 2 of those and leave me 1 left over on the top. The y's, I had 9 and I multiplied by 2 more, so now I have 11. So the answer would be 1xy to the 11 all over 4. It could also be written like this, 1/4 xy to the 11. They would both be the same. Okay, here's another example. Let's do another one like that one. Let's do, well, we'll do one similar here. Let's go negative 2 m squared n over 3 m n squared to the 4th power. So again, there's a lot of ways you can do this. If you want to, you could start off taking everything in here to the 4th power, top and bottom, numerator and denominator. But I think what I'm going to do is see if I can't cut down a little work here and simplify what's inside here before I take it all to the 4th power. So I notice I have 1m on bottom and 2 m's on top, so that's going to leave me 1m on top, 1m in the numerator. I have 1 n in the numerator, 2 n's in the denominator, so when those cancel, I have 1 in the denominator. So I'm going to rewrite my problem here. Negative 2 thirds, and I have an m in the numerator, an n in the denominator, and that's still to the 4th power. So now I'm going to go through and take everything to the 4th power, because I could just rewrite this 4 times and multiply straight across, but I'm going to try to do a little shortcut here. I'm going to take each thing in this parenthesis and take it to the 4th power. So I'm going to start with the negative. I have a negative times a negative times a negative times a negative. An even number of negatives turn this to a positive answer. And then I'm going to take 2 to the 4th power. So 2 times 2 times 2 times 2. And then I'm going to have m to the 4th power. And then 3 to the 4th power and n to the 4th power. And then let's see if we can go ahead and simplify that. 2 times 2 times 2 times 2 is 16, m to the 4th. And 3 times 3 times 3 times 3 is 81, n to the 4th. Nothing else cancels here because these are m's and those are n's. So that one's done. Okay, what happens when you have some that might multiply together? So let's try 2 of these multiplied together. Let's do y to the 10th over 2x cubed times, I'm going to get a different piece of paper here. I'm going to use a piece of typing paper so the lines aren't getting in the way. I'm going to rewrite this. So I had y to the 10th over 2x cubed times 20x to the 14 over x, y to the 6th. So there's a couple of ways you can work this problem. You can try to reduce and then multiply, or you can just multiply straight across and reduce at the end. I think I'm going to try to reduce in here, then multiply. So since nothing reduces on this one, I'm going to keep it the same. But on this one, I do have something that reduces. I have 1x in the denominator and 14 in the numerator. So this one is going to cancel with one of those and leave 13 in the numerator. So this is going to be 20 x to the 13 over y to the 6. So now I just have two fractions that I'm multiplying. And when you multiply fractions, you multiply straight across. So on the top, I have 20 x 13 y 10. And I could have written y 10 x 13, but typically you write in alphabetical order if it's just multiply. So then on the bottom, I have 2 x cubed y to the 6th. And Delta Math might be picky on that, so you'll have to watch that they aren't looking for a particular order. So now my coefficients, I'm going to reduce. 20 and 2 reduces to 10 in the numerator. I have 3 x's on bottom. That will cancel with 3 of these and leave me 10. And I have 6 y's in the denominator, 10 in the numerator, so that leaves me 4 in the numerator. So since there's nothing left here, I could put a 1 here if I wanted to, but since it's the denominator, we don't really need it. So that would be my answer. If it was the case that this was left on the denominator, we would have to put a 1 in the numerator if that was the particular problem, but it's not in this case. All right, let's do another more difficult problem. Let's do 32 a to the 4th b to the negative 2 over 2a to the 3rd b to the 3rd times 3a squared b to the 7 over negative 2a. Okay, I'm going to try to work this one the same way. I'm going to see if I can't reduce this term and reduce this term before I do my multiplying. So I'm going to start with the numbers here. 32 and 2. That will reduce and go to 16 and 1. Since the one's on the bottom, I don't have to put it there if I don't want to. I have 3 a's on the denominator, 4 up here. So these 3 cancel with 3 of those and leave me 1. This is a negative exponent, so I'm going to move it down here with the ones that are already there. So since I had 3 on bottom and I got 2 more, now I have 5 on bottom. And the bottom is the denominator. Okay, on the next one, 3 and 2 don't reduce, and I have a negative sign. It doesn't matter if the negative is with the top or the bottom. I'm just going to go ahead and leave it with the bottom for now. And I have 1a in the denominator, 2 in the numerator, so that leaves me 1 in the numerator, and then b to the 7. Now I'm ready to multiply. Multiply straight across. 16 times 3 is 48. A times a is a squared, because this is like a to the 1st and a to the 1st. B to the 7 over 1 times negative 2, which is negative 2, b to the 5th. Now I'm going to look to see if I can reduce again, and I can. 48 and 2 reduces, goes to 24 over 1. And since there's only one negative sign, I can put it on top, I can put it in the front, or I can put it at the bottom. I'm going to put it with just right in the front here this time. And then I have a to the 2nd, and then 5 b's in the denominator, 7 in the numerator, so that leaves me 2 left over. Last example of this kind. If I were you, I would pause this, try it myself before I watched. So 9x to the negative 3 over x to the 4th, y to the negative 5, times 3x squared y to the negative 2 over x y cubed. So we've got a lot of stuff to deal with here. So I'm just going to kind of go through in order here and see what I want to do. I notice that I have negative 3 exponent, so I'm going to move those to the bottom. I don't have anything to go with the 9, so I'm just going to keep it on top. So since I took these 3 and moved them down with the 4 that are already there, now I have 7 x's in the denominator. These 5 that are negative in the denominator are going to move up to the numerator and become positive. So now I have y to the 11th in the numerator. Times. So here, what I notice is I have this entire thing to a negative exponent. So this entire thing is going to move down to the bottom and move to a positive exponent. So now there's nothing left on top, so I have to put a 1 there. So now on top I have a 1. And I'm going to go ahead and deal with this before I combine it with these. So this is 3 squared, which is 9. X squared, squared is x to the 4th, and then y squared. So now I've got to put these together. So I have 9, and I have 1 and 4, so that makes 5 x's, and 3 and 2, so 5 y's. Now I'm ready to multiply straight across. So I have 9 y to the 11, and 9, I had 7 x's and 5 more, so now I have 12 x's, and y to the 5th. Whoops, sorry, went off the page. So now the 9's will cancel. I have 5 y's and 11 y's, which makes 6 y's. So my answer is y to the 6th in the numerator and x to the 12th in the denominator. And that won't reduce any because one of them is an x and the other is a y.